Hey, welcome to Notes 6.03. Today we're looking at mean proportionals. I'm really mean as a crazy math teacher. And what we like to call the path and whole rules, right? And what we're looking at here today is right triangles. Okay? So a mean proportional, we're going to get started by talking about of two different variables, A or B, two different values. Okay, the mean proportional of A and B is the value x here, where A compared to B is going to be a numerator to the opposite denominator, and X are our other pieces here and here, which are always going to repeat. Okay, so it might be in this position, bottom and top, it might be in this position, top to bottom, but the mean proportional is where we take a product of the means equals the product of the extremes. So when I cross multiply here, we always will get x squared equals the product of A times B. Sorry if that was off the screen. There we go. Product of the means equals product of the extremes. And I think I forgot an extra E in there. Where x times x will give you x squared, and the product in the opposite direction will give you A times B. Now this bar down the middle kind of just split that up. But what we're going to be looking at is right triangles. So notice here we have this right triangle ABC. Okay? So right triangle ABC is set on its hypotenuse AB. The big right triangle, so again, we like to focus on the big picture first. The big right triangle has other two pieces. So remember, when we're talking right triangles, I'm going to redraw that one there. If C is the right angle, this is a leg and this is a leg, like our A squared, our B squared, and the hypotenuse is down here. Okay, so if we're focused on triangle ACB, where we have a leg on this side and a leg on this side, when we draw this middle segment in from C straight down, that is called something pretty important. And I'm going to highlight here and I'm going to write it in. That is called our altitude. And when we draw that altitude in, okay, so again, when we draw the altitude in, it splits that right triangle now into three triangles. So we have the big yellow triangle. We're going to have this blue triangle. Which is triangle ACD. But now D is the right angle. So remember, an altitude is always perpendicular to its opposite side. And that other triangle to the right is triangle CDB. So again, when that altitude of the big triangle is drawn in, we create three triangles. Okay? Now that angle A is shared from this triangle to this triangle. That angle B is shared from the big triangle over to the orange triangle. So this triangle here, the yellow triangle, has two angles that are equal to each other. This angle of 90 and this angle of A, and then the third angle being B. That double arc carries over to here, double arc. So if triangle ACB will line up to triangle A, double arc to double arc, right angle C will correspond to this right angle D, and then C actually becomes what that angle B is. The last orange triangle from ACB, the big one, to become CDB, we know that angle C is going to be a double arc. So whatever this measure is would actually correspond up to here. So A and C in that case would be the same from this picture over to here. The right angle compared to D, and B compares to always B. So those letters kind of jump around based on where the right angle falls. But these three triangles end up being similar to one another because they always have at least two angles in common. So A and C are congruent angles that would match up to two angles here, meaning C would be the leftover measure. I know this angle and I know 90 here. C's got to be the same measure as B over there, and this angle here. So what happens is this big triangle with an altitude drawn in gives us three triangles that are each similar to another. And what happens is those parts then become positions. So it's a hypotenuse over here, AB, isn't a piece of either of these pictures. But this leg here becomes the hypotenuse on this one. So there's some magic going on in those three pictures, but there's a pattern formed, and we call this the altitude rule and the leg rule. The altitude rule is formed using this acronym PAAP. And looking back up to the picture, I'm going to tell you what the P's and the A's stand for. So P and P are parts. And looking at the large diagram, in this picture we have a leg, a hypotenuse, and an altitude. But when that altitude gets drawn in, it breaks the big hypotenuse into two pieces. So this is considered part 1, and this is considered part 2. So when we're looking at PAAP, how that works into a proportion, thinking product of the means and product of the extremes, notice the A's repeat. Okay, this is the first P and this is the second P, is that part 1 over an altitude measure, A for altitude, equals the altitude, the other A, over part 2. So PAAP, P-A-A-P, goes for part over altitude, altitude over part. So lining that up with the picture down here, part 1 would correspond to this 9. The altitude, again, altitude, altitude, we use the altitude rule when we're given an altitude, okay, is X. And the part 2 is dB, will be this 4. So those three pieces are going to fall into this proportion. But again, the altitude measure, like the product of the means, repeats itself. So with these three measures, 9 is going to correspond to X, as that altitude again corresponds to the other part. So it's kind of a little loop-de-loop. 9 corresponds to X as X corresponds to 4. So these should always be the same. And cross products to solve, X squared equals 9 times 4 is 36. We take the square root of each side. Now X is technically plus and minus 6. And that's a little reminder from algebra. X squared always gives you 2 answers for X at the end. But we are going to reject the negative 6 here. So in this case, X will equal positive 6. That altitude is positive 6. Now another way to think about this is this here, if we focus on the triangle on our left, is a leg to the base. Okay, 9 corresponds to X. If we're thinking about one triangle, 9 corresponds to X. As if I drew over the second triangle, 4 corresponds to X. So that's why the X repeats, is because it's shared between this triangle on the left and this triangle on the right. But what I'm going to tell you as a rule of thumb is that when you have an altitude, you're going to use the PAAP rule, where the part goes over the altitude as the altitude goes over the other part. So part is the 9, altitude is the X, repeats over the other part. Looking in the second picture. Now this picture is kind of rotated around. If we turn our paper back, is there anything next to the altitude here? There isn't. There's no measure there. We don't need that. So we're not going to use the altitude rule. We're going to use the leg rule. So the leg rule, or what I've highlighted kind of in yellow here. So the leg rule is this HLLP, HLLP from the top of your notes. So HLLP is when we have a leg. So you use the leg rule when there's no altitude measure given. Right? There's nothing next to the altitude, so it must be the leg rule. So H is going to stand for the hypotenuse. Over L is going to be your leg. Equals, and again, the leg repeats itself up top, and P is apart. Okay? And that's going to be the closest part. And I'll explain that with a picture here. So if this is the leg we're talking about, I'm going to highlight that in yellow to be our leg. That's what goes in the base and then repeats itself here. These measures of the 5 and the 4 are 2 parts. So remember, this whole big hypotenuse is the big hypotenuse here, where the altitude's kind of drawn into it. These are each a part. So this is maybe part 1, and this is part 2 of the whole hypotenuse. This whole hypotenuse measure is 9. So when we have our hypotenuse, okay, that whole measurement 9 is what goes in for the hypotenuse. And the part, which part do we use? We have to decide these two. If we're looking for this leg, we go for the leg that's the closest. So if I kind of use those highlighters to help myself find the pieces, the whole hypotenuse is 9. The leg measurements were X and X. And again, those should always repeat. This 4 is the part closest to the leg we're finding. And how that actually works, and some of you might understand this better, is if I forget about this altitude drawn in, and we look at the big triangle, 9 is the big hypotenuse, compares to the leg of that triangle. 9 compares to the leg, X, that we're finding. As if I focus on the teeny tiny triangle here, the hypotenuse there is X. If we rotate that around, and this is our right angle here, the hypotenuse compares to its leg. So again, we have the PAAP rule when we have a measure next to the altitude. We have the leg rule. Hypotenuse is the leg we're looking for. Now, X might not be on the leg all the time. The X variable isn't always going to be here, and I'll show you that down in these examples. The hypotenuse and the other part. So in this cross product, we get the same equation. X times X and 9 times 4 gives us 36. But those pieces of the puzzle were just in different locations. So in this case, again, X equals plus or minus 6. But our final answer is that this leg measurement from here to here is going to equal 6. Because we keep the positive answer. So looking at exercise 1, we have to decide which rule to use, the altitude rule or our leg rule. So looking at this picture, is there anything next to my altitude? No altitude means we use the leg rule, HLLP. Here we have an altitude, so we must use the altitude rule, which is PAAP. So yes to an altitude, since we have a value next to it. Now it happens to be our variable, it isn't over here. So the HLLP, again, is the hypotenuse of our picture over a leg equals a leg over a part. So looking at the picture, this 12 is representing this entire hypotenuse. So that means our hypotenuse is 12. That 4 is a part of this whole hypotenuse. Well, if that's 4, remember that this is 8 over here. So there's 2 parts. So the hypotenuse, the 8 and the 4, just like our original picture, there's 2 parts to make the whole hypotenuse. Okay. So the leg that they're looking for, that's our part. The leg that we're looking for is going to be the x. So substituting the pieces in, the hypotenuse is 12, the leg is x, which repeats up top, and the part is 4. So in this case, x times x gives us x squared. 12 times 4 gives us 48. Well, that's not a perfect square, so we got to go into the calculator. Remember, we undo a radical by taking the square root of 48. X approximates to 6.928. Okay? Sometimes we're asked to leave in simplest radical form. I'm going to come back to that with radicals soon. So looking at part B, so again, identify which rule to use first. This was the leg rule because there was no altitude measure given. Here, the altitude rule, the altitude is x. Remember, PAAP goes to part 1 over your altitude equals the altitude over part 2. Well, I don't know the 2 parts right now, so we do have to do a little subtraction. So if I know the whole hypotenuse, so remember this 25 is representing the whole hypotenuse. Subtract 9, we get 16, is the measure from here to here. So these are our 2 parts. So 16 is the part 1, and the 9 is going to be part 2. So substituting in the parts, 16 compares to the altitude x, as x compares to 9. X times x, remember, is always x squared. 16 times 9 gives us 144. And taking the square root, x is plus or minus 12. So we're going to say our altitude here is positive 12. Those were 2 different questions. One we used the hypotenuse rule, one we used the altitude rule. You can have a bunch of practice with that today. Wow. Exercise 2. Find dB, right? So dB is the variable x there, and we have to decide which rule to use. So there's HLLP or PAAP. So the A's, remember, are when we have an altitude. The L's are when we have the leg. So in this case, do I have anything next to my altitude? I don't. I don't need that. There's no measure there, so it's not going to be the altitude rule. We're going to be using HLLP here, HLLP. So to find our hypotenuse, that's the entire hypotenuse down at the base of this picture. This is 21 and this is x. The entire thing is x add 21. Okay. The 21 is a part, the x is a part, this 10 is your leg. So identifying those pieces, the hypotenuse, the leg, the altitude, is important. So that vocabulary that I did at the beginning and marked up the picture, I can see through my paper here, is important. So the whole hypotenuse goes in my numerator is x plus 21. The leg, L, the denominator is 10, that repeats. So here, my variable isn't on my leg like it had been in the other questions. A number can repeat, but it's, again, the same thing, numerator to that denominator. The part that we need is the part closest to this leg is x. So again, the hypotenuse is to its leg, as the hypotenuse of this little triangle is to its leg x. So that's why we need the part closer. 21 doesn't have anything to do with that 10 over there. Okay, they're in 2 different triangles. So cross multiplying, we get x times x plus 21 equals 10 times 10 is 100. And this is why we've been practicing some factoring. We get x squared plus 21x equals 100. Move your 100 over. X squared plus 21x minus 100 equals 0. I'd like you to pause the video, try to factor that on your own. What multiplies to 100 and adds to a positive 21. So pause the video, please, solve it, and restart. $25 times 4 does give us 100. So therefore, we have a negative 25 and a positive 4. Since we can't have negative measure, we're going to keep x to be 4. So the measure of d to b will be 4. A little check. You could test this in your calculator. So we want to test, does this match back up to here? So if x is 4, well, it's 4 plus 21 divided by 10, the same as 10 divided by x value of 4. They do. So 25 to 10 is the same as 10 to 4. So that's just to verify your answer back into the proportion we had to begin with. So again, very beginning of the question, you have to make a decision if it's HLLP or PAAP. Question 3. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are always. So here's a right triangle. Okay? The altitude is drawn in. Now most of you will see this picture and see that the height is here and the base is here. Okay? And most of you think altitude and height are exactly related, which they are. But what this is saying is the altitude is drawn to the hypotenuse. So that means from this right angle, I'm going to kind of rotate my paper around to show you that the altitude is drawn to make the hypotenuse, meaning the altitude is drawn to this hypotenuse. Okay. Well, that splits my big triangle into one triangle to the left, this triangle to the right, and the one we started with. And that altitude is what creates our similar triangles, right? And that's why these proportions help, right? Again, it's a pattern formed, and we name that pattern the HLLP or the PAAP rule to go through the question. Okay. Example 4, kind of the same idea. In the diagram below of right triangle ABC, an altitude is drawn to the hypotenuse AB. So here it was situated that the right angle is down to the bottom. Here the right angle of the big picture is up to the top. So an altitude is drawn to the hypotenuse AB. And all these pieces are then formed. I want to go through and label those. A, for the big shape, is a leg. A squared plus b squared, the other leg, equals the hypotenuse c squared. So that takes care of a couple of those variables. The x and the y are parts. We have part 1, x is from b to that altitude here, and y is part 2. Z is representing the altitude. So when we're thinking about these letters and these positions, we need to be thinking of these words. So again, the HLLP ratio always works. This is the same, remember, as L over H equals P over L. Okay? These cross products would give you the same thing. So remember, they might be in different positions. So let's read through these. Which proportion would always represent the correct relationship of the segment? C is to Z as Z is to Y. Well, C is a part, C is the hypotenuse. Is the hypotenuse to the altitude as the altitude is to a part? Is the hypotenuse to an altitude as an altitude is to a part? No. A's is the PAAP rule, not HAAP. So it's not choice one. We'd go through that for all three choices. C, again, is the hypotenuse, is to A, a leg, as the leg is, so again, hypotenuse is to leg A, as leg A is to Y over here. Doesn't work out. Now this is a part, but it's not the part closer, so it's not going to be choice two. X is to Z as Z is to Y. So X compares to Z as Z compares to Y. Is that a part to the altitude and altitude to the part? It does work. This falls directly in line with the PAAP rule. And there are a lot of multiple choice questions kind of similar to setting up those ratios. Last but not least, another roof question. Okay. So these application questions are meant to kind of prove to you that these concepts we're doing in our class apply right over your head on some roofs. So the roof of the house is represented by the cross section below. Use the dimensions given to find the altitude h. So we're finding the altitude. Now, with that measure, we have a hypotenuse, the leg here, another leg over here, and the hypotenuse down here. Now, if I knew AB, this would be a nice PAAP rule, where I'd have a part AD to the altitude as an altitude is to this part, but I don't have that piece. So what I need to do is find one of these parts first. So I'm going to set myself a note. I need to find DA or AB first. Because if I need this part here and this part here in order to find my altitude, I can't just take 6.3 and randomly break it into two numbers. So what we're going to do is I'm going to find this little piece AB here. I'm going to call it little a. Where little a is part of my hypotenuse. So I'm going to start with the HLLP rule, where I have the hypotenuse, I have my leg measure of 3.1, and I have the part I'm looking for, A. So our hypotenuse is 6.3. The leg I know is 3.1 and 3.1. And then I'm going to find part A, which is the other piece here. Which really, if I look through that, it's the hypotenuse to the leg of the big triangle. As focusing on the small one, the hypotenuse is to its leg. So cross multiplying, 3.1 times 3.1 gives us 9.16. So cross multiplying here, we get 6.3 times A equals 9.61. Divide by 6.3, and A will equal 1.5253. Now, this decimal, you check my calculator screen here, continues to keep going. There it goes. If you go 4 decimals out, 5253, right? It's going to help your rounding for the other answers. So what I have right now is that this little piece here, that part A, is 1.5253. If that's 1.5253, AD is going to be whatever 6.3 minus that is. So if I know the whole hypotenuse all the way across the 6.3, I'm going to take 6.3 and subtract my 1.5253. We get the other part here to be 4.7747. Now we can go through and use our PAAP rule. Okay? So we did one little version to use our HLLP rule. Now we're going to go and use our PAAP rule. That this part 4.7747 over our hypotenuse, our altitude h equals altitude h over our 1.5253. So cross products, h squared equals 4.7747 times 1.5253 gets you 7.2828. Then we take the square root of that answer, and we get h equals 2.698. Now it asks us to find it to the nearest, find the altitude. So I'm going to round this to about 2.7 because they gave me only one decimal place. 2.7 meters is going to be our final answer for that case. So it was a little tedious with the decimals, but that's what happens with some of these questions. Okay. So again, identify the pieces you have. So labeling the hypotenuse, the leg, the altitude is going to be to our best benefit. Looking at this example and these questions, some of you will struggle with questions 1 and 3 because you don't see a variable on your picture. So when we're asked to find CD, put next to CD. That's what we're looking for. That means CD is next to your altitude, so we need the PAAP rule. So we want you to set up the proportion. Part is to altitude as altitude is to part, and solve for x. If you have to round anything, because we will get decimals as we're taking some square roots, the general directions here says to round to the nearest tenths place. So a reminder on that, if you have 8.376, and this is my tenths place, your answer should be a 8.4. That 3 rounds up one more because of the 7. Right. Looking here, is there anything next to the altitude? Is there a variable next to the altitude? No altitude. Don't use the altitude rule because you don't have anything to put in for those two positions. So in this case, you're going to use the HLLP rule. So usually the biggest question I have is which rule to use when, right? Something else with that is you might have to do some subtraction along the way. So remember, if your whole hypotenuse is 12, if this is 8, this one would be 4 if you needed the parts instead of the hypotenuse, right? And again, QR here, they're asking you to find this side of your variable on the picture. Okay? Try what you can with the rest of these questions. There's 7 questions on the front. I kind of set up a couple of them there for you. On the back, question number 8, I pulled this question in because a lot of you were forgetting to separate your 2 triangles and to put the measures that correspond to each other in positions. Letter 9 is from notes today, and same with letter 10. Make sure to put the variable where you're looking in your pictures. Good luck. Thank you.